We're now going to start working on the player itself. I'll be working on very basic input for the moment. I'll be working on the prefabs folder, and I'll create another folder here. This folder will be for our player. In the scene I can then add an empty game object, and this will be added to my subscene, which is of course the sub-player subscene. I'll then place my capsule and cube beneath this game object. This game object will be renamed to player. I can drag this into my player folder and convert it into a prefab. That gives me a generic prefab for the player. This will make it easier to swap out different versions of the player in the future if I need to. I can now add a script for my player, so I'll go to the scripts folder and I'll add this within the player folder. I'll rename this script to auth player. This script can now be added to my player prefab, so I'll open the prefab and I'll add the script to the player itself. This will set up my basic hierarchy, so I can exit the prefab, and now I can start to work on the script itself. The authoring components will all be modern behaviors, and they purely serve as a link between the editor and the ECS framework. Essentially, this will allow us to say in the editor what we want our parameters to be, and this will convert those parameters to data for our ECS setup. I'll remove all the existing code from within this class. Next, we'll have our baker class. This should be called public class bake player. This will inherit a baker with the type auth player. We'll need to generate the bake override, and this is where we're going to add our components. Currently we do not have any components. The first component that I will add will be a tag component, which is essentially an empty component that I'll use to give a type to my entity. This component will be a struct, and it will be a public struct. This component is going to be a singleton component and will only ever be used on the player, so I will include it within the authoring component. Components which are not going to be specifically related to any single character will be placed in separate component scripts. This struct will be called tag player. It will inherit from iComponent data. This will be an empty struct. Next, I'll need to create a reference for my entity, and this is so we can add the components to it. I'll call the entity player entity. I'll set this using a getEntity method. This will take an enumeration, and this enumeration is transform usage flags. I'll set this to be dynamic. This means that we'll be adding transforms to this entity. I should now be able to add the component to my entity using the addComponent method. We're going to add this to our player entity, and the component that we're going to add will be a new tag player. This will give us the basic authoring for our player, and essentially we're only going to be adding our player tag to the player at the moment. I'll return to Unity. If we play now, we should see that our camera is still moving. I'll select my player. In the inspector, I should see a couple of tags. The simulator is by default, and this should be followed by tag player. There is only ever going to be one player within this game. Any game which I'm going to be making will be single player, and there will be no networking. We are now attaching components to our entities, so we can start to work with these. To do this, we'll need a system. I'll add an empty script, and this will be called sysPlayer. This script is going to be used to create the player itself. We can now edit this. This is not going to be a modern behavior. I'll need to bring in the entity libraries, so this will be using unity.entities. This will be a public partial struct, and this will implement an iSystem interface. We'll need to implement a few methods. The first will be public void onCreate. This will have a single argument. This will be a reference to a system state, which will be called state. There'll need to be a couple more of these methods. The second will be onUpdate, and the third will be onDestroy. These are the main methods we need. The majority of the work will be done in the onUpdate method. I'll start by creating a reference for my player. This will be an entity. I'll store this in the variable player. I'll get this with systemapi.getSingletonEntity. A singleton entity will be an entity which only occurs once in the scene. This being a single player game, there will only ever be one player. We will get the player using the tag player component. I'll also want a reference for my input entity. So I'll duplicate this. The entity name here will be input, and this will reference tag input. For anything that is going to be dynamic, we will need to calculate the delta time. So I'll want a reference for our delta time. This will be a float. The variable name will be delta time, and we'll set this with system API.time.delta time. Next, I want to get an input value for the character's position. This will be a float 3. This will be our position. This will be a 0 vector, and we'll set this with float3.0. We can then update our position. For example, we could have our position X, and we could set this with our right stick. However, we do not currently have a reference to the right stick, so we'll need to create this. I'll store this in a variable with var right stick. This will be set with system API.getComponent. This will be a right stick component, and we'll be getting this from our input entity. So now set my position at X with right stick.value.x. I'll then have position.y, and this will be set with right stick.value.y. I can then test this by logging a value. So I'll say debug.log, and I'll log the position. We can return to Unity to test. We should now be able to see our controller input logged to the screen, as we should get a value change whenever I manipulate the right stick. We can continue working on our scripts. I'll start by changing my camera system. The line where we update the camera movement will be commented out, as we do not currently need to set this. Having movement on the camera will make it more difficult to see movement of the player. We now want to move the player, so I'm going to use a for each loop. We'll want a variable for the transform, which we'll get with var transform, and we'll get this in system API.query. Here I'm going to look for a reference parameter, and it's a reference parameter which I want to be able to modify, so I'll use the method ref_rw, which is a read-write reference. We're going to reference an aspect, and this will be a local transform. We can then specify which entities we're going to test against. So we'll use .withAll, and we're going to look for everything with tag player. I can now work with my transform. So this will be transform.valueReadWrite. We are going to be setting the position. I'll set this with our position, and I'll multiply this by delta time. This should cause our position to be updated based on the value which we are providing from our right stick, and it should compensate for frame rate differences using delta time. I can return to Unity. I can play to test, and this says it is changing values, as we are seeing changes in the transforms for the entity. We're not currently seeing any actual position changes though. The reason for this is we are updating our position by a small amount, and then we are moving our character back to position 0. We're not actually updating the position. We actually need to set this as a cumulative value. So this will be plus equals position multiplied by delta time. I can test again, and I now have movement for the character. This will give us very basic movement for the character. This is not actually how I'm going to control the character movement. This will be replaced soon, but it does give us our basic input and does give us our initial control for the player. Next, we're going to make our basic camera setup.